A reminder, do not take the work out until all of the operations on this end are completed. Now the next thing I'm going to do is to drill the hole, so I've got a 1/4" starter bit in here, and lately I've been liking those starter bits better than a combination center drill. And then I'm going to drill it 11/30 seconds, not 3/8, not 3/8, 11/30 seconds, and you'll see why later. With this bit, and I have already marked it from the prototype. See the white mark on there? I know that seems a bit crude, but in drilling it from this direction, that'll give me the right depth that I want, and then I will cut it off after I turn the taper on there with the cutoff tool. And I will not have drilled deep enough to where I am going to have damaged the rest of the stock. So let me do that real quick, and now, one of the reasons I like to mark the drill bit rather than use the graduated quill is that sometimes the quill gets pushed away from the work, and then the hole isn't the right depth. I really do not like the clamping mechanism on the clausing lathe, because I just don't think you can get it tight enough sometimes. One of my very few criticisms of this wonderful machine. Clamping mechanism for that reason. It's very easy to unclamp it, slide the entire tailstock back, clear the chips, oil it, to the line. I don't know if I mentioned it yet, but the bell is a 60 degrees. 60-degree bell. So look at this setup, if you will, and you're going to see that I have the compound set at half a 60, which is 30. The carriage locked. I have already set this up so I know I have plenty of travel here to complete the cut, and I will not hit the chuck. And I calculated that before I even started the project. And of course now the feeding is going to be done by hand with the compound until the small diameter approximately equals the diameter of the shank here. And I really would like to, but I'm not going to. There's a rather beautiful transition on the Cushman with a radius. However, mine will just be a point where the angle meets the straight part. Now, there's no other good way to do that that I know of as far as putting the radius in other than the file, and I don't want to do that. So now I'm ready to cut. I'm back at 500 RPM. This, of course, is the compound rest method of paper turning, one of 3 methods, but the only one that allows an angle as steep. And of course, the tailstock cannot be used because it would interfere with compound. Now at this point, I'm feeding in with the cross feed to achieve my depth of cut. I'm getting very close to my last cut, not quite there, but it didn't take long. Clearance in here between the tool post and the work, and I am getting fairly close, but then again I'm down to my final cut almost. And this is my final pass. I'm feeding slowly and I'm using both hands on the compound rest dial to try to get a continuous feed. Like I probably will have to use a file and a little emery paper to smooth it off. The cut is not all that great. And just a little filing on the taper with a nice clean file. Be careful when filing. Make sure you have a handle. And so on. And just a little bit of abrasive paper. Some of you may have noticed that there is a slight angle on the end here. Looking at it this way, about 10 degrees. That's strictly for ornamentation, if you will. And here's the setup for that. The compound is set at 10 degrees off to the left, and I'm just putting a taper on the end. one last thing to do, and that is to either knurl it, and I am not going to knurl it, or make these little grooves, and I'm going to use a threading tool, 60-degree threading tool. You can use a cut-off tool or just about any tool that you want, or whatever kind of groove you want. And there's 4 grooves on here, and I'm going to make 5 just to extend it a little bit farther. And I'm going to touch off with the threading tool and then go in, I believe it's 30 thousandths. I'll correct myself if that's not the right amount. Now the first groove is to be 1/4 inch from the end, so using this I've already adjusted the carriage. And you can do a layout, put some bluing on here and do a layout. I'm going to use the stop, my carriage stop, and just move it 3/16 of an inch. There's 3/16 of an inch between each one of the grooves. Again, that's just ornamentation or for grip. I've touched off. I'm going to feed in 30 thousandths, and that's not enough, so I'm making it that's 50 thousandths, and I'm moving the carriage now 3/16 of an inch. $50 thousandths. So lightly. To get off the high spots, and that is done. At long last, all of the operations have performed such that I am now able to move the work in the chuck and cut it off. And I've already moved it out about 1/4 inch. I didn't have quite enough room to get in there with the cutoff tool. You can see I've got the cutoff tool here. That's a really narrow one, which I favor, although it's extremely delicate. And what I probably will do is to cut off 90% of it and finish it with a hacksaw. And hopefully I've drilled the hole deep enough so that I will run into the hole and then the work will come off. Now if you don't have decent cutoff equipment, you can saw it off, but hopefully you'll saw it straight. But we are going to be able to face it, so if you want to leave a little waste stock you can, because we're going to grip it by the shank here to do the work on the other end. Remember, this hole is not the final size yet. So with it in back gears, let me get started. And this is kind of a long operation, cutting off large stock on a light machine, but that'll go at it. By hand, not by power. I'm about halfway through and it's rather slow going, I must admit, but it beats a hacksaw. And I love this squirt bottle here for getting into the groove. gets the oil where I actually want it. The deeper I get, the faster I can run the spindle. The cutoff is complete, and I have reversed the work in the 3-jaw chuck, and now I'm trying to prove a point here, and that is how far off center this hole will be. That is how much run out. So I stuck the 3/32 bit in there, the same one that I drilled it with. Now take a look at it. Can you see how much it wobbles? Now I'm going to attempt to indicate that too, just to show you how far off it is. But the whole deal here now, and the reason I'm going into such great detail, is that I need to bore it from this side and then ream it to the final size. Now I've only got a 32nd of an inch to play with. I hope that it works out, and that's an awful long way to bore. So in fact, before I bore, I'm going to have to put somewhat of the taper in there, because I have to use a boring bar that is this small in diameter, and look at how precariously I have it hanging out. But I want to true the hole up when I can get to it, and then ream it. So that's the game plan here, to bring it true, and that is what caused this project to be a failure 49 years ago when I used it teaching. Wow, can you see the run out? There might be more run out there than what I can repair. I wish I would have drilled the hole a little bit smaller, but then I needed that size in order to fit the boring bar in it. But that's an awful lot of run out.